All right, in this video, we're going to cover the other very useful collection type called dictionaries. Dictionaries and arrays go hand in hand. They serve different purposes. Hopefully, you've already watched the videos on arrays, and you've also watched the concept video on dictionaries. So what I'm going to do here is jump in and do a little bit of coding and just review how we can declare and access dictionaries. So the dictionary is something that is considered unordered, different from arrays. Arrays are ordered. And as we remember, to get to elements of the array, we just give it an index. So it's index 0, 1, 2, 3, and it gets the various elements in the array based on that index. With dictionaries, we primarily will use strings as what we call the key into the dictionary. And that is how we find elements in a dictionary as opposed to an index number. So let's declare a dictionary. We'll start out var, like we do with all of our variables. And we'll do famous constants. And when we do that, we are going to basically use the name of the constant as our key in the dictionary. And then the constant itself, which will be a double, will be the value. So this is commonly referred to as a key value pair. Given this key, we get back a value. Remember, in arrays, given an index, we get back a value. So when we define a dictionary, it's almost like declaring an array, except it has this colon in between. So this is the start of declaring a dictionary, where we have an open left bracket, close right bracket, and we have a colon in between. And that colon in between is giving us a delimiter that we can specify what the key type is and what the value type is. So in our case, and in most all cases, when you do dictionaries, you're going to have string over there on the left-hand side. But on the right-hand side, it could be any number of things. In this case, because we're doing famous constants, we're going to just use a double. So we're going to type in double here. So now that we've done this, this essentially is how you declare a dictionary. A dictionary is always going to have a key and a value, and you have to tell it what the key type is, normally string, but doesn't have to be. And then on the right side, the value type, and the value type can be anything. And so we're going to do double. Now, one thing to keep in mind here too is that as we build up our dictionary of items, they always have to have double as the value. It's not a mix of, okay, sometimes when I do a key of this, I get back a string. Sometimes with given a key, I might get back an integer. No, you will always get back a double. Just like in arrays, as you index through an array, you're always going to get back the same type. So initializing a dictionary is very similar to initializing arrays. We can come here and say equals, and now I can specify key value pairs for the dictionary. And the way I do that, let's start out with an open left bracket, and we're going to specify our first key value pair. We do a key value pair using the colon. So the first key might be, let's say, pi, because that's going to be a famous constant. And then I'm going to put a colon here to represent the value, just like we did here, right? We have this colon between it. So right here is this colon. And now I can say 3.1415. And what I've done is I've now initialized the dictionary with a key of pi and a value of 3.1415. So without adding any more to the dictionary, let's just see what we have so far. If I come down here and I say print famous constants, and let's go ahead and build and run that, we see down here we get this open left bracket. Almost looks like it's going to be an array, but it's not an array because it has this colon in between. And so it's pi is the key, that's a string, value is that double. So I could, if I wanted to index into this dictionary, instead of giving it an index number like we do with arrays, we give it the key. So I say open left square bracket, I would say pi. And now when I run this, I get back this optional. Don't worry about that right now. But notice it says 3.1415. That's good. That's what we want. So we're getting back the value that is here based on the key that is here. Now, what if we wanted to give it another one? Well, then we would just put the comma here, just like you would with an array, and you'd do another one. So what if we did the speed of light, which is c? So we could say c colon, and in miles per hour, it's 186,282.396. And so that is the speed of light in miles per hour. And so now we have two of these. We have two key value pairs in our dictionary. And we could come over here and say C, and we could run that, and we'll still get that optional, but now we get back that value. So as you can see, we can associate a bunch of different things with different keys, and that's really the secret of dictionaries. Again, you want to watch the concept video to see why that's important, because there's a lot of different ways you could do this type of coding, and it really wouldn't be very maintainable. So dictionaries have this great ability to just say, give it a key and give it a value, and then I can look it up later. Just like a dictionary, you would think of like the Webster's Dictionary, where you look up things by words. So let's do one more. We'll do Earth's gravity. Again, I'll do a comma, and then I'll say Earth's gravity, and then we'll say colon 9.8, and that's in meters per second squared. And so again, I can run this. Of course, it's still doing C there, but what if I do Earth's gravity? And what if I make this G a lowercase, and I do a run? Now it's not going to find it. Now the reason it didn't find it is because these are all case sensitive. Your strings don't match if one is letter, even if it's just one letter that is lowercase and the other one was uppercase, they're not considered equal. So in this case, it tried to find a key that matched this, and it couldn't find it, and so it returned nil. So if you haven't covered optionals yet, there's a video on optionals, and I have a coding video with it as well. But I will just say here, the thing to keep in mind with optionals, or the concept is that sometimes we don't find things in the dictionary. So a dictionary doesn't necessarily have everything that you might expect that it should. And when it doesn't have it, when it can't find it, it doesn't crash. Like in an array, if I index past the size of the array, I'm going to get a crash. In a dictionary, it doesn't do that. It just says, well, it's empty, not there. So for example, we know that foo is not in there, right? There's no key called foo. And of course, when we run this, just like when we misspelled Earth's gravity or we changed the case, we are going to get a nil back, and that means that it was not there. So because this return type is an optional, it just means that when you look up something in a dictionary, it may or may not come back. And if it doesn't, you're going to have to test for that. And you can test, was it nil? Again, some other videos on that to do that. So this is how we declare a dictionary. And let's just do a little trick in our for loop so that we can build on that a little bit and see how we could use the for loop to iterate through what's in our dictionary. So the way we would do an array is we would do a for loop over the index numbers, 0, 1, 2, 3, 4. But with dictionaries, what do you think we're going to iterate over? Well, if we want to get these three values out, we need to iterate over the keys. But it turns out we don't really know what the keys are right up front. But we can find out by asking the dictionary for its keys. And we can do this through a for loop. So I can say for key, that's not a keyword. It could be any variable I wanted it to be. I just name it. It's typically called key because that's what it's going to be. It's going to be a key into the dictionary. In, and now the name of the dictionary, famous constants. So very much looking like an array, right? And in fact, if it was an array, I would do a dot count here. And then this could be like I for an index, and we would index through an array, but it's not, it's a dictionary. So right here, we can say dot, and I typed in a K and it completes keys. So what does this do? So we'll open that left bracket, close right bracket. What this is doing is famous constants dot keys is actually returning an array of keys. And this key is getting each one of those array strings. Let's just, before we run this, let's just do this. If I say print famous constants dot keys, and then we'll comment that out, and I will run this, we will see that we get back the keys. It's an array of strings, right? And we know it's an array and not a dictionary because we don't have a colon in here. We just have the comma. So we have this, comma, this, comma, this. So these are three different strings, and it just happens to be the three different keys in the dictionary. And you'll also notice that I declared the dictionary with pi first, then C, then Earth's gravity. But notice how it printed out the keys here. It printed C first, then pi, then Earth's gravity. The order here did not match the order here. And that's important to remember in dictionaries, is that a dictionary, as I said from the beginning, is unordered. That means that you may or may not get the keys back in the same order every time you run, and so you don't want to rely on that order. In fact, if I do this again, let's see if it changes. It did. See, now I ran it again, and I got the C for the first one, but now Earth's gravity is second and pi is third. So it doesn't necessarily matter in the sense of how we're going to go through the keys and print them, but it does mean that it's important for you to understand that with arrays, they are ordered 0, 1, 2, 3, 4, and they will always have that same order. You will not have any, there's no concept of an order with dictionaries. Okay, so now if I come back here to this for loop, and we'll take this print out. So we know we're going to get an array of three strings, and I'm going to use that key to reference the value in the dictionary. So I could say print famous constants, open left bracket, again, just like arrays, only we're doing it with a dictionary. We don't provide an index, right, because it's not numbered, but we do have a key. So we can say key here, and now when I run this, we see we get it turned out it gave us C first. That was the speed of light. Then it gave us pi, and then it gave us Earth's gravity at 9.8, and it gave us those values as we iterated through them. So this is an easy way to kind of go through this. Now, count also turns out to still give you a count. If I were to say print famous notice now I did print famous constants.count. I can do, there is a count attribute on dictionaries, and it's telling me how many key value pairs there are. And so this, by the way, this should always be equal to, what if I said famous constants.keys.count? That should also give me a 3, right? Because for the count is giving us the number of key value pairs. Keys is giving us all the keys. So it's giving us an array of all the keys. It should have the same count, and sure enough, it does. It comes back as a 3. So this is how you can declare and access and iterate over dictionaries.